Hey, Ultimus Flores. So today we're going to be talking about our ecosystem, particularly distinguishing the differences between living and non-living components in our ecosystem. An ecosystem is made of both living and non-living components. Things that would be considered non-living would be things like air, water, rocks, mineral, and sunlight. So things that don't have any kind of a living component to them at all. Living components would be things like plants, animals, bacteria, other types of life. So we're going to watch this video about an aquaponic farm and classify the components of the ecosystem as living or non-living.
We're an aquaponic farm. We use fish to generate our fertilizer, and the fertilizer is to uptake by the plants, and then the plants clean the water for the fish. So we have a completely recirculating, environmentally savvy ecosystem.
Sounds simple enough, but if you've ever run a farm or had your own backyard garden, you know there's more to it than that. For example, don't plants need special fertilizers?
We cultivate koi and tilapia. Any type of freshwater fish will work with aquaponics because what we're looking for them to do is pretty much produce waste. We're inputting feed, they're metabolizing that feed and generating ammonia. That ammonia then gets converted over to the most usable form of nitrogen, which is a nitrate, by a bacteria. It occurs naturally in any type of fresh water. So basically we're just mimicking what's happening in a freshwater environment and using that same science and technology to grow food.
We all know plants also need a lot of water to bring the fertilizer and nutrients to the plant's roots. At Green Acre Farms, pumps are used to move the water throughout the system.
We try to minimize how much electrical input we use, so we use primarily gravity flow to move the water throughout the system. So at the highest point is where the fish are. All that water is flowing downhill, essentially, to where the plants are. And from that lowest point, we take a pump and then we send that water up to the highest point. But it's incredibly efficient because we can reuse a really small pump. It only pulls about 145 watts to move over 12,000 gallons of water. We have several different types of aquaponic growing styles or systems. Primarily what you see in a commercial type setting is what we call deep water culture, which is essentially a floating raft, have the roots suspended down into the aquaponic nutrient-rich water below. Grow mostly leafy greens, lettuces in there. But what we also do is we grow with what's called media-based style growing or flood and drain. Tend to see that more in a backyard, a home gardener application. Fruit-producing crops go really well. Longer-term crops go very well in there. We also have NFT, which is a nutrient film technique. It's very common in hydroponics, but easily adaptable over to aquaponics. Have primarily herbs there.
With this approach to farming, Gina and her crew are able to provide a variety of produce for the local dinner tables year-round.
Leafy greens do exceptionally well. Fruit production crops do pretty well, so we can grow lettuces, collards, kales, broccoli, tomatoes, cucumbers, eggplant, pepper, certainly herbs, things like that. And then we get the added benefit of it grows faster. We don't have that competition that we have in the soil for fertilizer because there's so much of it abundant, and there's not a competition for those roots to have to really put out a lot of roots to reach out for those nutrients or for water. It's all right there. So that plant can invest its time and its energy growing up, producing the part we want, instead of growing down.
It may look simple, but aquaponics uses natural techniques in just the right balance.
So we have several different living organisms. It's not just the plants. There's fish, there's worms, there's bacteria that we have to consider. Make sure that we have a good environment for all of those living organisms.
And the results are high-quality organic produce that is completely safe and nutrient-rich.
We like to say we have the best certifier or regulatory agency out there, and that's thousands of fish that if I tried to introduce a chemical, I'd kill, and I'd effectively put myself out of business. We get absolutely clean food. Taste is phenomenal. We think that probably because there's no fertilizers, there's no chemicals, there's nothing to adulterate that taste. And it's incredibly fresh. So we can harvest that product out very first thing in the morning, have that to our client same day, and their clients are eating that salad that evening.
One of Gina's clients is Curtis Beebe, the owner of the local public house and provisions in San Antonio, Florida.
We are a public house of the old style in that we serve some great local brews and a couple of nice wines, and all of our food is prepared from local ingredients. Part of our core philosophy is that we try to buy stuff from local producers, folks that we know. We want to buy the highest quality product that we can find. We want the products to be sustainable and healthy and tasty. And the folks at Green Acre Aquaponics kind of check all those boxes for us.
Garden fresh organic salads are one of the more popular items on the menu, and Curtis never worries about running out.
It's all a super high quality product. They can produce salad greens all year round, which is a differentiator for them between the dirt farmers. It's just the best salad greens that I've ever had. I can count on them to provide a great product, and I don't have to second guess them. They share our ethos in terms of sustainability and high quality food.
So the best salads in San Antonio are all thanks to these little fishies and the crops they help produce.
You know, basically, I think it's the best way to grow food. It's sustainable, it's environmentally friendly, it uses less than 10% of the water that's used in traditional soil agriculture.
Gina now shares her expertise with others and shows people how to start their own aquaponics farm.
Whether it's a one-day backyard workshop where we teach folks how to do this on a small setting and they can grow food for themselves and their family. And we also do it in a larger scale where we teach people in 4 days how to replicate our business model, how to set up a small farm business, how to build the systems. We include construction drawings, essentially everything they need to get this farm business started. We're just really interested and invested in making sure more people learn about this technology, understand it, embrace it like we do, and make a greater impact on our food system.
All right, so let's talk about the components of that aquaponic farm. So their ecosystem consisted of a couple things. We had water, cucumbers, lettuce, bacteria, tilapia, which was a type of fish, nitrogen, and sunlight. So things that would be considered living or non-living. Water would be non-living, right? Definitely very important, but it is not alive. It is not living. Cucumbers, on the other hand, are living. They are plants. Lettuce as well. It's also a plant that is living in that ecosystem, and so is bacteria. Tilapia is a fish, right? Fish are animals, so that would definitely be considered living. Nitrogen would be non-living, as well as sunlight. So ecosystems need non-living and living things to be successful. Let's look at slide 27. Slide 27, we are going to watch another video about a farm, and we are going to be able to explain the interactions between soil, water, carbon dioxide, life, sunlight, and nitrogen that can help farmers grow crops. All right, now let's describe the interaction between the crops and another component of the ecosystem. So in the video, one of the examples I liked a lot is I liked their soybeans. So that man was talking about how soybeans have those nodules on their roots that allow bacteria to take the nitrogen from the atmosphere and turn it into a nitrogen nutrient for the plant. So we could say that soybeans use bacteria, which is important to them, that takes nitrogen from the atmosphere and turns it into a nitrogen nutrient that the plant can use. This makes it to where the farmers don't have to give nitrogen to the plant because the bacteria is already doing it for them. So for the soybeans, bacteria is very important to their development and growth. That's just one example. Y'all can come up with multiple examples if you want.